Welcome. This is the sixth and final video about the mathematics of elections. And in this video, we're not going to discuss any voting method in particular, but we're going to discuss why we can't just choose one of these methods and call it a day. So you may have been asking yourself, why are there all these different methods? Can't we just choose the best one and not have to learn all these different ways to count people's choices up? And in this video, we're just going to discuss why there's not a really good best option. So the first topic we need to discuss is an impossibility theorem. So a theorem means fact. Fact. No, none of that. It just means fact. And in this case, an impossibility theorem is a type of fact that says something can't be done. So example is, have you ever heard anybody say, you're trying to square that circle or something like that? It means you're trying to do something that's impossible. So where this is coming from, what squaring a circle is there's this problem in geometry that people have been asking for thousands of years, which is, if you're given a circle, let's see, let's do a better circle. Given a circle, can you use a compass, which is a tool that draws circles? You probably all are familiar with it. It kind of looks like this. It's got two arms, and then in one arm is a sharp point, and then the other one's a pencil. Can you use a compass and a straight edge, which means a ruler but without marks on it, to make a square? But not just any old square, with the same area as the circle. That was the goal of trying to square a circle, is to make the square that had the same area as a given circle using just these two tools. And it took mathematicians thousands of years, but finally it was proven to be impossible. Proved impossible in 1882. So if you want to make that square, you just can't do it if these are the only tools that you allow yourself. That's an example of an impossibility theorem. Let's adapt this to our subject at hand. So there was an economist mathematician named Kenneth Arrow, and he developed these so-called fairness criteria, which is just a list of things that should be true regarding an election in order for that election to be fair. Now, these are like things that the voting method should follow. And when we say fairness here, we're not talking about like everybody has access to the polls. We're not talking about everybody having the ability to go to the polls and vote and like not have to pay a poll tax or something like that. These are more characteristics of how you tabulate the opinions of people. And let's talk about the first one. Maybe that'll help illuminate what we mean by a fairness criteria. So the majority criterion is the first one we're going to look at here. And it says that if on all those ballots that you get, some candidate has a majority of first place votes, then that candidate should win. It's like if there's 10 people voting and 6 of them chose candidate A as their number one choice, then candidate A should just win. There shouldn't be some weird thing you can do with your voting method where in some situation A loses. The Condorcet criterion refers to if you are to run out the pairwise comparison method, then if there is a candidate that always wins, then that candidate should be the winner of the whole election. So it's not always the case that there is a Condorcet candidate, but if there is one, so it's if there is a candidate who beats every other candidate in the pairwise elections, then that candidate should be the winner. The next criterion is the monotonicity criterion, and it says that, listen, you shouldn't be able to like have a winner and then you like, oh, they like look like the clear winner, and then somebody, if you were to like change a single ballot and improve or increase that individual's ranking, the winner's ranking on that ballot, that should never hurt that candidate. So you kind of run a hypothetical. If some of the voters had moved that candidate to a higher rank on their ballot, that should never hurt the winner. And then the last criteria we have here is the independence of irrelevant alternatives criterion. That one is a mouthful. But again, it imagines a hypothetical. So if you have a candidate that wins, you shouldn't be able to go and be like, well, actually, we need to run this election as if candidate B were never in it. That shouldn't change the outcome of the election if B were not the winner. So you had some election, A was supposed to be the winner, and then A was the winner, and then for some reason later you found out that B should have been disqualified for whatever reason. And then you go back to all the ballots and cross out B. That shouldn't hurt A because B was not the winner. So that's what they mean by an irrelevant alternative, someone who lost the election. So those are 4 standards that every voting method should meet. And that's why they're called the fairness criteria. And the theorem is that if you want to design a voting method system that uses a ranked ballot and you want it to follow these 4 criteria, then that is an impossible task. So given the criterion, the task is to use a ranked ballot to make a voting system that never violates any of these. And the fact is, this is impossible. So our buddy Kenneth Arrow won a Nobel Prize for understanding the study of voting methods. It's kind of a downer. The conclusion is not that there aren't better voting systems. The conclusion is that there is no best voting method. Let's talk about one of those methods being violated. One of those criteria being violated by the board account method. So let's look at this example. We use the preference schedule to show that the board account method can violate the majority criterion. The majority criterion says if someone has a majority of first place votes, then they should win. And we can see that, we don't need to write that again, it's right above, but note that there are 11 voters in this election. And A got 6 first place votes. The majority criterion would say, listen, A should win. More than half of the people voted A as number 1. Let's check the board account method though. Using board account, that's the one where people get assigned points for the rankings that they get. A gets 4 points for 6 first place votes. 0, oops. They would have got 3 points for every second place vote, but A doesn't get any second place votes. A only gets first and fourth place votes. They would have got 2 points for every third place on the ballot, but they don't have any of those. And they get 1 point for every fourth place. So in total, we have 24 and 5 makes 29 points. B gets 4 points for the 2 first place votes that B was awarded. Let's mark these so it's easier to read. 3 points for every one of the 6 second place votes that B receives. 2 points for every 3 third place vote that B receives. And 1 point for none of the fourth place votes that B received. So we have 8 plus 18 plus 6, which equals 24 plus 6 is 30 points. So B, So B defeats A. And this is a violation of the majority criterion because B wins in the board account, but A has a majority of number 1 rankings. Okay, and as it turns out, all of the voting methods that we've discussed will violate at least one of the fairness criteria at least some of the time. It doesn't mean that they violate the criteria all of the time, and it doesn't mean that for some of the voting methods, they'll always adhere to some of the criterion. But if you can produce a preference schedule that doesn't work for one of the voting methods with one of the criterion, then that is enough to say that there's no perfect method. Okay, hope you enjoyed that. See you next time.